This thing writes poetry, debugs code, explains quantum physics. It really feels like something in there is thinking. So here's what's genuinely strange. Underneath all of it, a large language model is doing exactly one thing. Guessing the next word, that's the whole trick. It's autocomplete, just scaled up so absurdly far that it started doing things nobody expected. And how it guesses is one of the most beautiful ideas in computing. Let's open it up. First problem, a computer can't read. It does math. So step one is turning text into numbers. The text gets chopped into pieces called tokens. And tokens aren't quite words, they're chunks. Common words are usually one token. Rare or long ones get split. Unbelievable might become unbelieve-able. Rough rule of thumb. A token averages about 3/4 of a word. Every token has an ID number in a giant vocabulary. So your sentence goes in as text and becomes a row of numbers. This is exactly why AI pricing is per token. You're literally paying per chunk. Now the clever part. A token ID is just a label. Cat is number 4721, means nothing on its own. So each token gets converted into an embedding, a long list of numbers that represents its meaning as a position in space. Imagine a vast space where every word is a point, and words with similar meanings sit near each other. Cat, dog, hamster, same neighborhood. King, queen, prince, a different one entirely. And here's what gets people hooked. Directions carry meaning too. The step from man to king is roughly the step from woman to queen. Meaning becomes geometry. Full honesty, that's an illustration, not a perfect law. Real spaces are messier. But the core holds. The model isn't storing definitions. It's storing relationships. But there's a problem. Words don't have one meaning. I sat on the bank of the river. I withdrew cash from the bank. Same word, totally different thing. So the model needs context. And this is the transformer's big idea. It's called attention. The intuition. Every word gets to look at every other word and ask, which of you actually matter to me? For bank in the first sentence, river screams loudly. In the second, cash does. And the meaning shifts. That point in space physically moves toward shore or toward money. So words stop being fixed dots and start being dots that absorb their surroundings. Stack that over dozens of layers, and each position isn't holding a word anymore. It's a word plus everything relevant around it. That's the T in GPT transformer. So tokens in, context mixed in, and now the payoff. The model does not output a sentence. It outputs a probability for every single token in its vocabulary. The cat sat on the blank mat, 41%. Floor, 12. Couch, 9. Thousands of options. It picks one, sticks it on the end. And then this is the key, it runs the entire thing again with the new word included. Predict, append, repeat. That loop is what you're watching when text streams onto your screen one word at a time. It's not typing out a thought it already had, it's deciding, at every step, what comes next. And it doesn't always take the top pick. There's a dial called temperature. Turn it down, safe, repetitive. Turn it up, creative, and eventually nonsense. But where does the ability come from? Nobody programmed grammar or facts into it. Training, 2 phases. Phase 1, pretraining. Feed it an ocean of text and play one game endlessly. Hide the next word, make it guess, check the answer. When it's wrong, nudge its internal dials, its weights, slightly toward being right. Do that billions of times. And here's the magic. To get good at guessing the next word, it's forced to learn everything underneath. Grammar, facts, reasoning, code, all of it, because all of it helps you guess better. Nobody taught it. It fell out of the game. Phase 2, post-training. Humans rank answers, be helpful, don't be awful. That stage, often called RLHF, turns a text predictor into an assistant. Phase 1 gives knowledge. Phase 2 gives manners. Now everything weird about LLMs suddenly makes sense. Why does it hallucinate? Because it was never optimizing for truth. It optimizes for plausible. A fake citation is extremely plausible, perfect format, real-sounding author. It's not lying. It doesn't know the difference. It's just completing the pattern. Why does it forget? Because it only sees what's inside its context window, a fixed-size frame. Push in too much, and the earliest stuff slides out the back. Why doesn't it know about last week? Its knowledge froze at its training cutoff. And this is exactly the problem RAG solves, handing it fresh documents before it answers. Every famous LLM flaw traces straight back to the mechanism. It's not broken. It's doing precisely what it was built to do. Which leaves the big one. Is it thinking? I'll be honest rather than give you a hot take because this is genuinely unsettled. One camp says, it's statistics, a fancy pattern matcher with no understanding. It has no idea what a cat is, it just knows which numbers cluster near cat. The other camp says, to predict text this well, you'd have to build some internal model of how the world works. And maybe that's not so different from understanding. Serious researchers sit on both sides. What we can say for sure is the mechanism. Tokens, embeddings, attention, predict-append-repeat. Whether that adds up to thinking, that's still an open and genuinely fascinating question. So that's a large language model. Chop text into tokens. Turn tokens into positions in a space of meaning. Let every word look at every other and absorb its context. Then guess the next token, and do it again and again. Fair warning, I simplified. Real models are messier than any 7-minute video. But that's the shape of it, the engine under everything else. Agents, RAG, voice assistants. All of it sits on this. Next, I'm going deeper into attention, the one idea that made all of it possible. Subscribe for AI engineering explained visually and tell me, after seeing the mechanism, does it feel more impressive or less?